It's capturing everyone's imagination lately. It's this whole realm of augmented reality and spatial computing.
Oh, definitely.
The excitement around these new technologies feels like it's just building and building.
It truly is a pivotal moment.
Yeah.
We're kind of on the verge of fundamentally changing how we interact with the digital world around us.
Exactly. And that's precisely what we're diving deep into today. We're exploring the current landscape and the exciting future of augmented reality. We've gathered a really interesting set of sources from the practical guides developers use for platforms like, say, Apple Vision Pro and Android XR,
Right.
to fascinating research on how we as humans interact with these digital layers, plus, the latest news from the industry keeping us in the know.
Our goal, as always, is to synthesize all of this information for you. We want to provide a clear and engaging understanding of what AR actually is, how it works, its magic,
Yeah.
the incredible variety of ways it's already being used, and those truly groundbreaking developments on the horizon.
And don't worry, we're keeping the technical stuff, easy to grasp.
Absolutely.
We're hunting for those surprising insights, those aha moments that cut through the hype. For instance, would you believe that the very early seeds of what we now call AR were sown way back in 1957?
It's pretty wild, isn't it?
We'll be digging into that and a whole lot more. Okay, so let's start at the beginning. What exactly is augmented reality?
Well, in essence, augmented reality is a technology that overlays digital elements. Think of images, animations, text, sounds onto our view of the real world.
Okay.
This is primarily done through apps on our smartphones or, dedicated devices like headsets. So it's about enhancing our existing reality with digital information.
So it's not about creating a completely separate virtual world like in VR.
No, not at all.
AR is about taking what we already see and adding to it. But how do these apps actually manage to place those digital elements so they look like they're really there in our real world view?
That's where the clever technology comes in. AR apps generally use one of two main approaches, or sometimes a combination of both.
Okay.
The first involves physical markers, things like QR codes or specific images. The app uses the device's camera to scan and recognize this marker,
Right.
and then it overlays the digital content in relation to that marker. Think of it as the marker being an anchor for the digital information.
Kind of like scanning a QR code and having a website pop up on your phone, but instead it's a 3D object that looks like it's sitting right on your desk.
Exactly. The second and increasingly common approach is markerless AR.
Okay, markerless.
This uses the device's built-in sensors like GPS to know your location, accelerometers to sense movement, and sophisticated computer vision to understand the environment around you.
Right.
These apps can recognize surfaces, identify objects, and understand where the device is in space, which allows them to place digital content that appears to be realistically integrated into your surroundings and viewable from different angles.
That's the technology behind those fun social media filters that give you animated ears, or those incredibly useful apps that let you visualize if a new piece of furniture would actually fit in your living room.
Precisely.
Speaking of history, you mentioned that early AR-like machine. Tell us more about that.
Yeah, what's fascinating here is that this early concept predates even the invention of the term augmented reality. Back in 1957, an inventor named Morton Heilig created something called the Sensorama.
Sensorama.
Yeah, it was this large, booth-like machine designed to give viewers fully immersive theatrical experiences, complete with synchronized smells and sounds, along with the visuals.
Wow, smells too.
Yeah, it was a remarkably ambitious idea for its time, really highlighting a long-standing human desire for richer, more immersive experiences, even if the technology of the day couldn't fully realize it.
Huh.
Unfortunately, it didn't secure the necessary funding to become widely adopted.
Wow. A smell-o-vision precursor to AR. And then the actual term augmented reality came into use much later, right?
Correct. It wasn't until 1990 that the term augmented reality was coined by a researcher at Boeing named Thomas Caudell.
Boeing. Interesting.
Yeah, his work involved specialized glasses that helped electricians assemble the complex wiring in the Boeing 777 aircraft.
Ah, okay.
So in its initial stages, AR was very much a tool for industrial applications, used in settings like aircraft hangars and manufacturing plants to boost efficiency and accuracy.
It's really amazing to see the journey from those specialized industrial uses to the widespread availability we have today with smartphones and, increasingly advanced AR glasses.
It's a huge leap.
Okay, so we now have a good understanding of what AR is and the basic ways it works. Let's explore the different kinds of AR applications we see out there.
Okay, well, as we mentioned, we have marker-based AR, which relies on those physical triggers like QR codes.
Right, the anchors.
It's historically significant because it was one of the first ways to really demonstrate the potential of overlaying digital content onto the real world and helped establish some early ideas about how users might interact with AR.
And then we transition to markerless AR, which feels much more intuitive and is what most people likely encounter regularly now.
Exactly. Markerless AR encompasses a few key categories. First, there's location-based AR.
Yeah.
These apps use your device's GPS to pinpoint your location and then overlay digital content that's relevant to that specific place.
Like Pokemon Go.
The quintessential example here is Pokemon Go,
Yeah.
where virtual Pokemon appear in your real-world surroundings based on where you are geographically.
Right.
Google Maps, with its feature that superimposes walking directions onto your live camera feed, is another excellent example of how location-based AR can be incredibly practical.
Right. Those are incredibly useful in navigating the real world. What's the other main type of markerless AR?
That would be projection-based AR. This isn't as common in everyday consumer use yet, but can be very impactful in specific contexts.
Well, does that work?
It involves using projectors to overlay digital images directly onto physical objects or surfaces. You've probably seen this in museum exhibits,
Oh, yeah.
where static artifacts are brought to life with projected animations and informational displays.
That's really fascinating. It adds a whole new layer of interaction and information directly onto physical spaces.
Mm-hmm.
Now, let's talk about some of these popular AR applications that are out in the wild and the kind of impact they're having. We've already mentioned Pokemon Go, which, let's be honest, was a massive cultural phenomenon.
Huge.
Over 1 billion downloads. That's just staggering.
It really was.
It really showed the power of location-based AR to drive real-world activity and social interaction, setting a precedent for future AR experiences that aim to bridge the digital and physical.
It truly was, and it perfectly illustrated how AR could blend the real and virtual worlds in a compelling way for a massive audience. Then you have something like Google Lens.
Right, built into phones.
Which is integrated into many Android phones.
Yeah.
It uses your camera to recognize objects, translate text in real time, help you find products to buy, even read documents aloud.
It's pretty amazing, actually.
It's a remarkably versatile tool that quietly integrates AR into our daily routines and is subtly changing how we consume information.
It's almost become an invisible utility, but incredibly powerful in the way it connects the visual world with digital information. And then there's the whole area of virtual try-ons, which feels like it's really changing the landscape of online shopping.
Oh, absolutely. What's interesting here is how AR is addressing a key limitation of online shopping, the inability to physically interact with a product before buying.
Right, will it actually look good on me? Probably.
Exactly. We've seen fashion brands like Warby Parker for eyeglasses and even luxury brands like Prada and Burberry allowing you to virtually try on clothing and accessories using your phone's camera. This helps bridge the gap between the convenience of online shopping and the desire to see how something will actually look on you in the real world.
It definitely takes away a lot of the uncertainty and reduces the likelihood of returns.
For sure.
And it's not just fashion, right? Furniture is another significant area.
Absolutely. Imagine being able to visualize a life-sized virtual sofa in your actual living room before you even consider purchasing it.
That would save a lot of hassle.
Right. Cheesecake Labs, in fact, developed an entire AR furniture store experience. Their app allows you to point your phone or tablet, browse through a selection of furniture, and then tap to see it appear in your own space.
Wow.
You can even capture photos and videos to share with others. This really highlights how AR can enhance the shopping experience beyond just seeing product photos.
That's brilliant. So you can really get a sense of scale and how it integrates with your existing home decor. What are the potential commercial benefits of something like that for businesses?
Well, the potential is substantial. By enabling customers to virtually try before they buy, it can lead to higher sales conversion rates and a decrease in product returns.
Makes sense.
Retailers can also utilize the in-app data to refine their marketing efforts, suggest related items, and identify popular trends.
Okay.
Moreover, the social sharing aspect can generate organic buzz and attract new customers.
Makes perfect sense. Now, shifting focus slightly, how is AR making an impact in fields like sports and entertainment?
We're seeing AR enhance the viewing experience for sports broadcasts in really engaging ways. ESPN, for instance, uses AR overlays to display real-time player statistics and biographical information right on the screen during a game.
Oh, yeah, I've seen that. It's pretty cool.
Apparently, incorporating AR into these broadcasts has been shown to significantly increase viewer engagement and how long they tune in.
That's fantastic for fans, but it's not just about watching, is it? AR is also changing how athletes train and improve their skills.
Indeed. AR can simulate a wide range of realistic training scenarios, making practice sessions much more effective.
How so?
And because AR devices can display immediate data like angles, distances, and speed, it enables incredibly precise training for a professional athlete.
Right.
But it's not just for the elite.
Right.
There are now apps that use your smartphone camera to analyze your technique in sports like soccer or golf, overlaying virtual models of perfect form for you to compare against in real time.
So it's like having a virtual coach providing instant visual feedback.
Exactly. Democratizing access to expert-level feedback.
Yeah.
That's pretty powerful.
Yeah, it really is. And what about education? It feels like AR could be a real game changer in how we learn.
It really holds immense potential. AR has the capacity to make learning far more immersive and interactive. We're seeing the development of interactive textbooks that literally come to life with 3D models and simulations you can manipulate. Snapchat, for example, has partnered with Inspirit to create an entire AR-based STEM curriculum.
Wow.
This approach can make complex subjects much more tangible and understandable.
That sounds way more engaging than just passively reading text and looking at static diagrams.
Absolutely. And AR is also making significant strides in vocational training. Consider learning how to weld or fit pipes in a safe, realistic virtual environment.
Oh, yeah, that makes sense.
Which can also lead to significant reductions in training costs and risks. Companies like Lincoln Electric are already integrating AR into their welder training programs. And even entire countries like Nigeria are investing in AR to upskill their workforce. Even in professional development, such as training aircraft mechanics, AR can superimpose step-by-step instructions directly onto real-world equipment.
Wow.
Guiding trainees through complex procedures.
It's incredible to see AR moving beyond just entertainment and becoming such a practical and impactful tool across so many different sectors.
It really is branching out.
So where does the AR market currently stand, and what are some of the most exciting emerging technologies we should be paying attention to?
Well, the market is definitely maturing and gaining momentum, largely driven by the availability of more user-friendly devices. A major player in this space right now is undoubtedly Apple with their Vision Pro.
Right, the spatial computer.
Exactly. While they're marketing it as a spatial computer rather than a traditional AR or VR headset, it's fundamentally a very advanced platform for augmented reality development.
That $3,499 price tag certainly got people talking.
It did.
But what makes it such a significant platform for AR innovation?
Well, despite the different terminology, it's packed with cutting-edge AR technology. Apple has created a spatial operating system called Vision OS.
Vision OS, right?
Which allows users to interact with digital content that feels present in their physical space, primarily using their eyes, hands, and voice as input methods.
Very intuitive control.
Yeah. They've also released a comprehensive set of tools for developers, what's known as a software development kit, or SDK. And the ecosystem of apps for the platform has grown remarkably quickly, already exceeding 1,000. They've even been running developer labs and providing developer kits to encourage this rapid growth.
So even with the premium price point, it's clearly generating significant interest and activity in the AR development community.
Definitely seems that way.
What about the other major players in the tech world? Meta has also been actively involved in AR.
That's right. Meta's AR smart glasses have been positioned as a more affordable and accessible alternative to devices like the Vision Pro.
Okay.
Aiming for a more seamless integration into our everyday lives without being as visually prominent.
Kind of a more subtle, less obtrusive way to experience augmented reality in our daily routines.
Yeah, potentially.
And what has Google been developing in this space? They've been exploring AR for quite some time, haven't they?
Google has been demonstrating some truly compelling advancements. At the recent TED 2025 conference, they showcased AI-powered AR glasses that connect to their Gemini AI on your smartphone.
Oh, interesting.
Offering real-time language translation, the ability to identify objects in your environment, and much more.
Wow.
They also gave a preview of a mixed reality headset they're developing in collaboration with Samsung, with the codename Muhan.
Muhan.
Yeah. This headset features the ability to see the real world through cameras, what's called pass-through video, and supports displaying multiple digital windows in your view.
The idea of having AI seamlessly integrated into AR glasses for instant information and assistance sounds incredibly powerful.
It really does, like a significant step forward.
Tell us more about the specifics of Google's glasses.
Well, what's particularly interesting is their emphasis on creating a lightweight design. These glasses essentially work in conjunction with your phone, offloading much of the processing,
okay.
which allows the glasses themselves to be considerably lighter. In terms of how the digital image is displayed, they're using what's called a monocular, full-color diffractive waveguide architecture.
Monocular, so just one eye.
Essentially, yes. This means the AR display is currently only projected onto the right eye. While this likely contributes to the sleek form factor, it might have some limitations in the field of view. How much of your vision the digital content covers, and the eye box, which is the optimal area where your eye needs to be positioned to see the entire display clearly.
Interesting. So it sounds like a trade-off between the physical form and the completeness of the immersive experience, at least for now.
That seems likely, yeah.
And what about the actual display technology they're using to project the image? That seems like a really critical component.
Yeah, the specifics of the microdisplay are still somewhat under wraps. Based on the demonstrations, it appears to be more of a miniature optical engine.
Okay.
Given the challenges of achieving brightness and efficiency with diffractive waveguides, it's speculated that they might be using a liquid crystal on silicon, or LCOS, optical engine.
LCOS.
Or possibly a very small array of individual red, green, and blue light-emitting diodes, known as micro-LEDs.
Micro-LEDs, right. Google bought that company, Raxium.
Exactly. So there's speculation they might have made progress in creating very small, bright, full-color micro-LED panels. Each of these display technologies has its own advantages and disadvantages in terms of brightness, power consumption, and size.
That would be a significant advancement if they pulled off micro-LEDs well. And are there any clues as to who might be supplying some of the other key hardware components, like the waveguide?
There are rumors suggesting that Shanghai KY, a company based in China, could be their supplier for the waveguides. They reportedly collaborated with Google on a previous AR glasses project. There's also been some discussion about the potential use of materials like silicon carbide for the waveguide, similar to what Meta has been exploring.
Right.
But given the current focus on a potentially smaller field of view, that might be less likely at this stage.
So it seems Google is really prioritizing the seamless integration of AI as the key differentiating factor for their AR glasses.
That looks like the strategy.
Perhaps shifting away from some of their earlier, more complex AR hardware endeavors like North Focals and ANTVR.
Yeah, it feels like a different approach, emphasizing the AI capabilities as the core value proposition this time around.
Now, alongside these hardware innovations, what's happening on the software side to make AR development more accessible? You mentioned Android XR.
Right. Google recently announced the Android XR SDK developer preview. This is designed to empower developers to build XR, which encompasses both AR and VR applications, using the familiar tools and frameworks of the Android ecosystem.
Okay, using familiar tools is key.
Yeah. Exactly. They offer the Jetpack XR SDK for developers working with Kotlin and Android Studio, Android XR extensions for Unity for those in the game development space, and importantly, support for WebXR and the open standard OpenXR, promoting cross-platform compatibility.
So the goal is to make it easier for the large community of existing Android developers to get involved in creating XR experiences.
Precisely. The emphasis is on leveraging the existing Android ecosystem and ensuring broad compatibility across different devices.
Okay.
Interestingly, all compatible mobile and large-screen apps will be available for installation on Android XR headsets through the Google Play Store.
Oh, really? Just like that?
Although developers will need to consider how well these apps adapt to the XR environment to ensure a good user experience. You can't just assume a phone app works perfectly in a headset.
Right, there's work to do there. That's still a smart strategy to quickly build up the content library, though.
Definitely.
Now, for someone considering developing an AR application, what kind of costs and considerations are typically involved? It can't be an inexpensive undertaking, can it?
Well, as is often the case with software development, the answer is a classic "it depends" scenario.
Figures.
The cost of creating an AR app can vary significantly based on a number of factors, including the quantity and complexity of the 3D models required.
Okay.
The level of interactivity these virtual objects need to have with the real world and the user, and the specific target devices you're developing for.
Give us a couple of tangible examples to help illustrate that range in cost.
Certainly. Developing a relatively simple AR app that essentially places a single 3D object in a real-world scene, utilizing a platform like Eighth Wall and assuming you already have the 3D model created,
Right.
could potentially take around 1 month and cost in the ballpark of under $30,000.
Okay, that sounds like a potentially manageable investment for a basic AR application. What about a project with more features?
Right. If you're looking at a more complex application featuring a life-size virtual object that users can manipulate in terms of position and size, perhaps with animated textures and the functionality to record and share their interactions,
Getting fancier.
that could take approximately 3 months to develop and have a cost in the region of around $100,000.
Wow, okay. That's a substantial increase.
Uh-huh.
What are some of the specific elements that tend to drive up the complexity and therefore the cost of AR development?
Factors that significantly increase complexity and cost include the need to integrate multiple distinct virtual objects into the scene, requiring very precise alignment of these virtual elements with specific physical objects in the real world,
Tricky.
and enabling intricate user interactions with the 3D object's internal structure or its animated rigging. Ultimately, a fully featured AR application project can range from tens of thousands to hundreds of thousands of dollars, depending on the overall scope and the specific features and functionalities required.
And I imagine developing specifically for a cutting-edge platform like Vision Pro might also initially involve higher costs.
That's plausible, yeah.
Yeah.
Due to the need for specialized development tools or potentially needing access to specific hardware for testing.
It's clear that careful planning and a thorough understanding of the desired features are essential right from the start to manage development costs effectively.
Absolutely crucial.
Now, we've discussed the technical aspects quite a bit, but what about the human side of things? How does the field of human-computer interaction, or HCI, need to adapt for these immersive AR environments?
That's a really crucial consideration. HCI and AR moves beyond the traditional screen-based interfaces we're accustomed to with keyboards and mice.
Right. It's not just pointing and clicking.
Exactly. In AR, we're dealing with spatial interactions, voice commands, and even haptic feedback systems that simulate touch. Understanding how users perceive and naturally interact with these virtual elements within a three-dimensional physical space is absolutely paramount for creating effective and user-friendly AR experiences.
So the old rules don't always apply.
Well, the fundamental principles of user-centered design still apply, but the ways we apply them need to evolve. Not entirely. While some foundational user-centered design principles remain relevant, AR introduces a unique set of challenges and considerations. For example, cognitive load becomes a significant factor.
Cognitive load.
Yeah, users are simultaneously processing the real world and the overlaid virtual elements, so it's crucial to design interfaces that minimize distractions and avoid overwhelming the user with too much visual or interactive information.
Makes sense.
Concepts like the feeling of immersion, the sense of being surrounded by the virtual environment and presence, the feeling that the virtual elements are actually there in your real space, are also key aspects that designers need to consider in AR.
And I can imagine that prolonged use of these immersive technologies could potentially lead to issues like user fatigue.
Absolutely. Cognitive overload from constantly managing virtual elements, poorly integrated digital content, or even just the visual strain of continuously processing two layers of reality can contribute to user fatigue,
Right.
which ultimately detracts from the experience and can hinder performance. Designing comfortable and effective AR systems means being mindful of these potential issues and perhaps incorporating features like natural breaks or periods of less intensive interaction.
So user experience design for AR is really about creating interfaces that feel intuitive and contextually appropriate within this blended reality, while also prioritizing the user's comfort and avoiding cognitive overload.
That sums it up well.
Now, a particularly fascinating area within HCI for AR seems to be eye tracking. We're seeing this technology become increasingly integrated into AR devices and even smartphones. How does eye tracking technology actually work?
Eye tracking technology typically uses infrared light sources and specialized cameras to monitor where a user is looking.
Infrared, okay.
By detecting the reflections of this light off the surface of the user's eyes, the system can accurately determine their fixation points, where their gaze lingers, and the rapid eye movements between these points, known as saccades.
Fixations and saccades, got it.
What's becoming particularly interesting is that eye tracking technology is even becoming more accessible through built-in features on modern smartphones.
So it's not just limited to specialized and expensive AR headsets anymore. How can this kind of detailed data about where a user is looking be valuable in the field of UX design for AR applications?
Oh, it's incredibly valuable. Eye tracking provides a wealth of objective data about how users visually process information within an interface.
Objective data, that's key.
Exactly. By analyzing visual representations like gaze plots, which show the sequence of where a user looked, and heat maps, which visually highlight the areas that receive the most attention.
Heat maps, right.
Designers can gain valuable insights into visual pathways, identify elements of interest, and pinpoint areas that users might be overlooking or finding confusing. This data can then directly inform design improvements, making interfaces more intuitive and efficient.
So it tells you what they actually look at, not just what they say they look at.
Precisely. Importantly, eye tracking can reveal subconscious behaviors and instinctive reactions to visual stimuli that users might not even be consciously aware of or able to articulate. So it goes beyond just what users say they look at.
That's incredibly insightful. Being able to objectively see where users actually focus their attention could really be a game changer for refining the usability of AR interfaces.
It really could.
How do researchers and designers typically go about conducting these eye tracking studies?
The process usually begins with clearly defining the research questions and formulating specific hypotheses.
Okay.
Researchers then determine the key metrics they want to track, such as fixation duration or the number of saccades, and design specific tasks and visual materials for the study. The study itself can be conducted in a controlled laboratory setting, or, increasingly, remotely. The study can be moderated, where a researcher observes the user's behavior, or unmoderated.
Unmoderated or unmoderated.
Yeah. To generate reliable heat maps that show aggregate visual attention, it's generally recommended to have a sample size of around 30 participants.
30. Okay.
Following data collection, researchers analyze the visual data gaze plots, heat maps, and even video replays of the user's gaze to identify patterns and potential areas for design improvement. They often supplement this quantitative data with qualitative methods like user interviews to gain a more comprehensive understanding of the user experience.
So it's a blend of objective visual data and subjective feedback from the users themselves.
Exactly. That combination is usually the most powerful.
What are some practical tips for those looking to conduct effective eye tracking tests?
Several key practices can enhance the effectiveness of eye tracking studies. It's often beneficial to start with a smaller number of participants, perhaps 5 or fewer in initial pilot studies.
Pilot studies, okay.
To quickly identify major usability issues and then iterate on the design based on those initial findings before conducting larger-scale testing.
Makes sense. Find the big problems first.
Right. Thorough preparation of the eye tracking equipment is crucial to minimize technical difficulties during the test sessions. Encouraging participants to interact with realistic data, such as filling out forms with their own information,
Oh, yeah.
can provide more authentic insights into how the interface would be used in real-world scenarios.
Good point.
Taking detailed notes on participant behavior and any verbal feedback they provide alongside the eye tracking data offers valuable contextual information. And finally, engaging in a post-test dialogue with participants can often uncover valuable insights and rationales behind their visual behavior that the visual data alone might not reveal.
That makes perfect sense. It's about combining the objective insights from the eye tracking technology with the subjective understanding gained from interacting with the users.
Precisely.
Are there specific metrics derived from eye tracking that are particularly informative for UX design?
Yes, there are several key metrics that provide valuable information. Fixation duration, which is how long a user's gaze remains on a specific point, can indicate the level of interest, difficulty in understanding, or the importance of that element.
Okay. Fixation duration.
Saccades, the rapid eye movements between fixations, help us understand how users scan and navigate through the interface. Pupil dilation can even offer insights into cognitive load or the level of interest.
Pupil dilation. Wow.
Yeah. The gaze path, which is the sequence of fixations and saccades, visually maps how a user processes information. And the time to first fixation, which is how quickly a user's gaze is drawn to a particular element, can indicate its salience or prominence.
Right, what grabs their attention first.
Exactly. And heat maps, as we discussed, provide a visual aggregation of fixation data showing overall attention hotspots.
So each of these metrics provides a different piece of the puzzle in understanding how a user is visually interacting with the AR interface.
That's a good way to put it.
And you mentioned earlier that eye tracking can also contribute to enhancing design accessibility. How does that work in practice?
By gaining a precise understanding of where users are looking and how they visually navigate an interface, designers can create more intuitive and inclusive designs.
How so?
For example, if eye tracking data consistently shows that users with certain visual impairments struggle to locate a particular interactive element, the designer can make it more visually prominent, reposition it in a more predictable location, or provide alternative ways to access that functionality.
Right.
This ability to understand the specific visual patterns of different user groups is invaluable in creating more accessible and user-friendly AR experiences for everyone.
That's a really important and impactful application of the technology, making things work better for more people.
Absolutely.
Finally, I came across some information about research exploring the use of eye tracking to assist individuals with dyslexia. That's a fascinating potential application.
It is. Research is actively investigating how eye tracking can help identify specific reading difficulties, often associated with dyslexia, and potentially provide personalized learning pathways.
Personalized learning, okay.
Individuals with dyslexia often face unique challenges with processing text-heavy learning materials, and eye tracking offers the potential for solutions like automatically triggering audio playback of text,
Oh, wow.
or simplifying reading prompts when the system detects patterns of difficulty based on the user's eye movement patterns.
So it adapts based on how they're reading.
Potentially, yes. By analyzing the distinct visual patterns exhibited by dyslexic readers, such as more frequent regressions, longer fixation durations on certain words, or erratic scanning patterns, educators and developers can create more user-centered eye-tracking systems and tailor the learning experience to individual needs,
Right.
offering more effective and personalized support.
That's an incredible potential application of eye tracking technology, offering the promise of personalized support for learners who often face significant hurdles with traditional educational methods.
It's a really promising area.
Okay, so we've covered a vast amount of ground on the fundamentals and diverse applications of AR. Let's turn our attention back to developing specifically for some of these newer and more advanced platforms. Apple's Vision Pro, with its Vision OS, seems like a particularly unique and powerful system. What's involved in creating these immersive spatial experiences for it?
Right. Apple provides a dedicated Vision OS software development kit, or SDK, which enables developers to take advantage of the unique capabilities of the platform.
The SDK, okay?
Familiar Apple development tools like Xcode and the Swift UI framework are still central to the development process, along with Apple's 3D rendering frameworks like RealityKit and ARKit, which have been adapted for spatial computing.
So familiar tools, but adapted.
Exactly. They also provide TestFlight for distributing and testing pre-release versions of your apps.
What are some of the novel types of immersive content that developers can create specifically for Vision Pro and Vision OS?
The Vision OS introduces new paradigms for immersive content, including standard 2D windows that can now have a sense of depth.
Windows with depth. Cool.
Point 3D volumes that can be viewed and interacted with from any angle within your space, and fully immersive 3D environments called spaces that can completely replace your surroundings.
Spaces, so full immersion.
Right. Apple also provides a powerful tool called Reality Composer Pro, which is specifically designed for optimizing 3D content, including models, animations, images, and sounds for the unique demands of the Vision Pro.
Reality Composer Pro. Got it.
And they offer a Vision OS simulator, which is an invaluable tool that allows developers to test their applications in various simulated spatial layouts and lighting conditions without initially needing access to the physical Vision Pro hardware.
The simulator is key for early dev.
Absolutely. It's also important to note that Apple's commitment to accessibility is reflected in built-in support for various accessibility features within the developer frameworks.
And for developers who might already have existing 3D applications built using other popular platforms, such as Unity.
Unity has announced official support for porting existing 3D applications to the Vision Pro platform, which will significantly expand the range of content available on the device from day one and make it easier for developers with prior experience to enter the Vision OS ecosystem.
That's great news for developers and will likely lead to a more diverse and richer app store. Are there any early examples of Vision Pro applications that really showcase the potential of the platform?
Absolutely. Elsevier Health has developed an application called Complete HeartX.
For medical education.
Exactly. Which utilizes incredibly realistic and detailed 3D models of the human heart to help medical students gain a deeper understanding of complex anatomical structures and medical conditions.
Wow.
Algorithm's popular DJ app, DJ, has been reimagined for Vision Pro, bringing a full-featured DJ system into a spatial interface, allowing users to mix music using intuitive eye and hand gestures.
DJing with your eyes and hands.
Yeah. JIXSpace is enabling businesses to leverage their existing CAD files to create interactive 3D product presentations and collaborative experiences.
Useful for business.
And PTC has an application called Stages that allows manufacturers to collaborate on complex 3D models for design reviews and operational decision-making. These early examples really highlight the broad range of powerful and practical applications that Vision Pro is enabling across different industries.
Those sound like truly immersive and incredibly practical uses of the technology, really pushing the boundaries of what's possible.
They really do.
You even uncovered some specific details about the technical aspects of developing for Vision Pro, particularly regarding the creation of these volumetric windows.
Yes, there's a really informative video that walks through the fundamental process. Essentially, when you create a volumetric window within Vision OS using RealityKit and SwiftUI, you define its style as explicitly volumetric.
Your volumetric style.
And then specify its initial dimensions in terms of height, width, and depth, effectively creating a 3D bounding box in space. You then load your 3D virtual entities into a reality view that is placed within that defined volumetric window.
Right, loading the 3D stuff into the box.
Interestingly, the coordinate system within these volumetric windows in Vision OS has the y-axis oriented upwards.
Y's up. Got it.
The video also provides helpful debugging tips, such as enabling the visualization of the volumetric window's boundaries and coordinate axes within the simulator, which aids in understanding the spatial relationships and positioning of your virtual content.
Helpful for debugging.
Very. It's important to remember that when you're adjusting the position of your 3D object, you're doing so relative to the origin and within the defined extents of that specific volumetric window, rather than in the broader, unbounded spatial environment.
So positioning is relative to that window. That's a really helpful technical insight for anyone looking to start developing for the platform.
Yeah, understanding those coordinates is key.
Now, before we wrap up our deep dive, let's briefly revisit Meta. You mentioned their ongoing work with AR smart glasses, but they also have a research initiative called Project Area Gen 2. What's the primary focus of that project?
Right, Project Area Gen 2 primarily serves as Meta's research platform for advancing the development of future AR glasses.
So it's for research, not consumers yet.
Exactly. The core focus of these research glasses is on collecting real-world data to inform and refine their future consumer-facing AR products.
Collecting data in the real world.
Yes. And given the nature of this data collection, privacy is a paramount concern. Meta has established clear and transparent guidelines regarding where and when data collection is permitted, with strict restrictions in sensitive environments.
Privacy controls are important there.
Absolutely. Users also have comprehensive controls to stop data recording and delete collected data through a companion application.
So it's more about gathering valuable insights and data to guide the development of future consumer products rather than being a consumer-ready device in its own right at this stage.
Exactly. It's a critical step in understanding user behavior in real-world AR scenarios and refining the underlying technologies and user experiences for their eventual consumer AR glasses.
Well, this has been an absolutely fascinating and incredibly comprehensive deep dive into the dynamic world of augmented reality.
It's moving fast.
Let's quickly recap some of the most significant takeaways we've uncovered today.
Okay. We've seen how AR is a rapidly progressing field with a diverse range of applications transforming areas from entertainment and retail to education and professional training.
Definitely broad applications.
The emergence of new and powerful hardware platforms like Apple Vision Pro, alongside ongoing developments in Meta's smart glasses and Google's prototypes,
Lots of new hardware.
coupled with advancements in software ecosystems like Vision OS and Android XR, are significantly lowering the barriers for developers and paving the way for increasingly immersive, practical, and user-friendly augmented reality experiences.
And we've also explored the vital role of human-computer interaction in ensuring that these AR experiences are intuitive and comfortable for users,
Crucial.
with eye tracking standing out as a particularly powerful and insightful tool for understanding user behavior and enhancing the accessibility of these new interfaces.
Eye tracking is really interesting there, yeah. What's truly remarkable is the convergence of these different technological advancements, powerful and energy-efficient hardware, sophisticated and user-friendly software platforms, and a deeper understanding of how humans perceive and interact with digital information overlaid onto the real world,
It's all coming together.
all pointing towards a near future where the digital and physical realms are more seamlessly and meaningfully integrated into our daily lives.
It really makes you consider the profound implications of these advancements for how we access and interact with information, how we learn and collaborate, and even how we connect with each other in the very near future.
Potential is huge.
So for you, our listener, what are the specific new possibilities that these rapidly evolving technologies unlock that you find most intriguing or potentially transformative? Are there particular applications or areas of development that you'd be especially keen to explore further? That's your food for thought following this deep dive.
Lots to think about.
Thanks so much for joining us.